Welcome to Cocos 2D Tutorials, brought to you by Bob Hewland. For more information, go to bobhewland.com/cocos2d. This tutorial is called Steering Behaviors. The steering is the problem of how to simulate movement of intelligent objects like birds, animals, cars, etc. Craig Reynolds was one of the first who investigated this problem, and he came up with several steering behavior examples. Here are some of them: seek and flee, pursue and evade, wander, arrival, obstacle avoidance, containment, wall following, path following, flow field following, queuing, crowd path following, leader following, collision avoidance, flocking. In our tutorial, we will look at the wander steering behavior. We want to make an object wander about on the scene in something that looks like a natural roaming movement. If we have an object like the bird here, which has a constant velocity, it will move in a straight line. If we want the bird to wander about, we must change the velocity. Now, the velocity is a vector that has a speed and a direction. In our wander movement, we want to keep the speed constant, which means that we must vary the direction. However, varying the components of the direction directly, with random numbers, gives an erratic movement which does not look at all like wandering. The idea that Reynolds had was to take sight at some new object and steer towards it. That new object might move erratically, but if the relation between our original object and the new object is cleverly designed, our object should be able to produce the right kind of movement. We take a circle and place it in the direction of the bird. The circle will have a certain radius and be at a certain distance from the bird. At the perimeter of the circle, we place a point which we'll call the target. The point will have a certain angle with respect to the x-axis. The idea is to let the bird steer toward the target point, which will give a new velocity. Adding the noise to the angle will make the target point move erratically along the perimeter of the circle. And if we are lucky, that will produce the wandering movement for the bird. Let's go to Xcode and see how this is done. We are inside Xcode. Our task is to make a moving object wander around on the screen. Our plan is to use the wander steering behavior as described by Craig Reynolds. Let's look at our starting point. We have 4 images: background, bird, circle, and target, which is just a red point. If we look at our interface file, we have 3 sprites: bird, circle, and target. We have a point called velocity. We have 5 floats: speed, radius, distance, angle, and angle noise. And then we have a point called target location. Let's look at the implementation file. We can see that we have two groups of methods, a math group and the initialization group. The first method in the math group returns a random number, starting at start and ending at end. Next method takes a vector as input and scales it so that it has the length 1. Then we have a method called angle for vector, which takes a vector as input and returns the corresponding angle. Then we have a method called wraparound, which monitors the bird's position, and if that position is outside the screen area, it wraps it around so it starts on the other side. If we look at the initialization group, we see the init method. Here we just call 3 methods: add background, set parameters, and add sprites. Add background just puts the background image on the screen. Set parameters just puts some values into our parameters. And add sprites adds the bird, the circle, and the target on the screen. Let's run this and see how it looks. And there we have our 3 sprites: the bird, the circle, and the target. In order to get these sprites to move, we have to call the schedule update method and then change the position of the sprites for each update step. Stop. Let's go to our init method and write self schedule update. This will call the update method 60 times per second. Let's write the update method. Update cc time delta time, and inside here we need to change the position of our sprites. Let's begin with the bird. We want to steer the bird toward the target, so we take the vector from the target to the bird, normalize it, so we get the desired direction. Then we multiply this direction with the speed, which gives us the new velocity. Having the velocity, we can calculate the new position of the bird, and also the rotation. Then we just check if the bird is outside the screen, in which case we wrap the bird around. That's everything we have to do with the bird. Let's now find the center of our circle. We begin by looking at which direction the bird is pointing. It is pointing in the direction of the velocity. So we normalize the vector and then we multiply it by the distance, which gives us a vector that starts at origin, pointing in the same direction as the bird, and having the length distance. We translate the vector so it begins at the bird's location, and we get the circle location. The next step is to calculate the location of the target. We begin with the old angle and add some noise to it. So we get the new angle. By taking the cosine and sine of that angle, we get a unit vector pointing in the new direction. By scaling it up with radius, we get the desired vector, except that it starts at the origin instead of the circle center. But that we fix easily by translating it to the circle location. And there is our target location. And the last thing we need to do is to update the positions of the circle and the target sprites. Let's run this. As you can see, the bird is following the target. In our finished project, we don't want to see the circle and the target, just the bird. Stop. If we look at our code, we see that the only parameter we use to find the new velocity is the target location. And that has nothing to do with the circle and target sprites. So we can just eliminate those two sprites. Also in the add sprites method, we can just delete, and also in the interface file. Let's run it once more. And as you can see, it moves just like before. If we look a little closer at the movement of the bird, it looks more like the movement of a mouse than a soaring bird. But we should be able to fix that by tweaking our parameters. Stop. Let's go to our parameters. Decrease the noise. Increase the distance to the circle. Make the radius of the circle a little smaller. Run this. And as you can see, the steering behavior is much more bird-like this time. Thank you for watching.